Industry 4.0, the future is now, is the name of this talk. But what exactly is Industry 4.0? I must admit I hadn't actually heard of that term until you invited me to do the talk.
It's a German invention. Industry 4.0 is basically, it's actually a German invention. It's a term coined 2 years ago by German industry to describe what happens when you connect machines to supply chains and everything else. So it's the industry of the future, networked machines that talk to each other and that interact with people and other machines. So it's basically, the civilian version of it is called the Internet of Things. The industrial version is Industry 4.0. We started working with Evo 2 years ago, roughly. And we basically started thinking about the future of lighting and what Evo does. And what Evo does is quite interesting. They make public lighting systems that are actually systems, that are not just cold systems, they're real systems, because you can configure them and you have a variety of circuit boards with LEDs on it, high-powered LEDs, and then you have a whole range of different optics you can attach to them and basically build exactly the lamp you need and want at any time. And into this system, we added a little bit of intelligence. So it's this little black box there. It's basically a little computer that lives in the lamp and is able to understand what's happening under the pole this light is mounted on. So we basically are able to control and set rules and basically realize when is this light even needed. If there's nobody there, you don't really need a street light. So what we do is we use advanced image recognition, and basically you're able to track objects, you're able to tell cars from pedestrians, etc., etc.
It just shows how quickly things are moving forwards, because it was only 3 or 4 years ago that The Economist did a big cover feature called We're at the dawn of the third industrial revolution. The first industrial revolution was, of course, steel and heavy industry and mass production. Second industrial revolution was in the 20th century with the introduction of the microchip and so on and so forth. And now we're in the third industrial revolution, which is suddenly things like 3D printing and the way that technology enables the fast iteration of designs and the mass production of designs. But Industry 4.0 suggests we're in a new paradigm already, just 3 years later. It's getting hard even for a journalist to keep up. Clemens, you've put together a little presentation that talks us through some of the projects you've done over the years, which will touch on these issues. Do you want to just talk us through those?
Yes. Breeding tables was about growing structures in the computer using genetic algorithms, using advanced software that actually knows how the machine works. So we program a CAD application that only lets you draw things that the machine afterwards can produce. So it's not like AutoCAD or like any Illustrator or whatever. You can draw buildings 7 kilometers high. They would instantly collapse if you actually built them. We restrict that to things that are doable, makeable, buildable, and will stand up and actually function as tables. And we also put all the intelligence related to the whole process of making the table, of painting the table, of shipping the table into this application. It's a sort of all-encompassing tool that enables an entire process and also eliminates a lot of the obstacles on the way that you have when you produce things, because you have to translate drawings into files, you have to load the files onto machines, etc., etc. So the ambition here was really to use massive industrial machinery by Trumpf, laser cutters, brake bending machines, at the same ease you use a 3D printer, basically. But not doing additive manufacturing, but rather plugging into machines and activating latent potential that's out there, that's already exists in industry. What we're trying to do here is really to understand how do we design and how can we design tools that help us design in much closer contact with machinery. How can we document knowledge that we gain during a process? How can we document it and ultimately make it available? So this is all the tables that resulted from this project in the first year, and all of them are made with the same machine, with the same process, and you just put in different sizes. What we didn't do here is we didn't hand this tool over to third parties. So we kept kept it to ourselves. So we were still the authors, still the designers. We designed these objects. We just used a piece of software to help us. And in the next project I'm going to show you, we're going to go one step further. This project is called Outraised. Outraised basically was for the London Design Festival 2010. They invited us to do the key installation on Trafalgar Square and didn't have any budget. And so we wanted to do something with robots and hand over control over these massive machines to the public. We basically programmed the robots and taught them how to write. You could send a message to the robots through the internet as an SMS or by email, and then the robots would draw your message with these light brushes. 36 cameras around the plinth would record these letters, and if you played back those 36 images, you would get a scrolling message that you would receive in your email as a little YouTube video link. This is a really important waypoint towards something called Industry 4.0, because there was a proof of concept that it works. Yes, you can hook up computers to the internet, and yes, you can get people to get involved. RoboShop 2015 was the first time we went, okay, let's make objects and let's get people to actually design things. So with breeding tables, we only, we were the authors, we would design things using the software. 2015, we felt comfortable enough to actually let people design their own objects. The way it works is you go to roboshop.com/chop. On your phone or computer or tablet, you will find a 3D interface that allows you to cut foam blocks virtually. We write a robot program, send that to the robot, and the robot will cut your design using a hot wire tool. Your finger movements will be translated into robot programs and ultimately into robot movements, and you're able to manipulate a foam block 50 by 50 by 50 centimeters. Somebody from industry will see this as a perfect technology demonstrator of what Industry 4.0 is. Because you have user input, you deliver an idea or a specification through the internet to an industrial plant, ship it to the customer in the end. That's what Industry 4.0 is supposed to be. But we see it as something bigger. It's an idea, it's a proof of concept for a way of designing tools that allow us and others to make things.
Design is a very optimistic profession, and technology in the early days was very optimistic that the internet and open source would make everyone freer and be able to share stuff. How do we kind of ensure that we keep control of that vision, that it doesn't all become used to sinister ends?
Over the last couple of weeks, there has been many headline items in the sort of nerd press about IoT devices being hacked. So Internet of Things, if everything is on the internet, everything becomes vulnerable to attacks. So Samsung's entire home automation kit, which is a lovely little box, you open it, you plug it in, you can remotely control lights, you have a thermostat, etc. People just hacked it to the most ridiculous degree. So everybody was switching on lights in other people's buildings, etc. So there's a lot of, there's a lot of potential there, but also lots of threats, because what is more fun than switching other people's lights on and off? So taking robots online is as dangerous as anything you put on the web can be attacked. So the whole Industry 4.0 initiative is also, it's easy to do a demonstrator like what we did here with RoboShop. It's not completely easy, but it's doable. But it's only doable because we check every single program that we receive, because of course there's hackers, and we had when we did it, we had it up for 1 week, and within less than 24 hours people managed to hack it, and they basically tried to drive the robots into the floor, because it's quite easy. If you put minus 1 meter 20 on the Z axis, the robot will just go and destroy itself. So we basically wrote a little program that checks everything. But you need to put, even for a technology demonstrator, you have to put these measures into place. Otherwise, the whole thing can spin out of control. So it's all about building systems that are really safe.
Thank you so much, Clemens. Thank you all so much for coming.
Thanks for coming.
Thanks, Clemens.